morning, Mrs. Heidenreich here, and this video is going to talk about the differences between the regular function f of x versus a transformed function such as f of x plus h, where the plus h is inside with the x. So if we know anything about transformations, we know that if a number is being added or subtracted to x, that the function will move kind of in the opposite direction in which we're expecting. So if it says x plus a number, it's actually going to move left. So what I want to talk about is why that happens, and I'm going to just kind of showcase a few examples. So a lot of times in math, the best thing to do when you're not sure about something generally is to just try it with some numbers. So let's pretend that we have a function f of x, and we want to figure out how that's related to the function f of x plus 1. So we're only going to add 1 to it. Now again, it'd really help if we could look at a specific example. So a parent function that we could have would be something like y equals x squared, or f of x equals x squared. Okay. Now, if we wanted to graph that function, it would be a simple parabola. At 0, 0, we would have a point at 1, 1, 2, 4, and so on. And then on the left side, a symmetrical portion of the graph. Okay, so this is our regular old parabola. Now, if we wanted to add plus 1 inside, that would look like this. F of x plus 1, whoops, gotta get my plus 1 in there. We would have x plus 1, sorry, this is getting a little light here with my rainbow color, and then we would square it. Now for the sake of the discussion, I am not going to actually multiply x plus 1 times x plus 1 and then graph that parabola. Often we would do that. But I'm going to simply call this function g of x. G of x. I'm going to graph this function by plugging in some numbers. Okay, I'm going to say first of all that I want to see where that vertex of the parabola moved. That will tell me a lot about which way the function is moving. So I'm going to look here. This point used to be 0, 0 for the parent function. Where has it moved? Now the way to tell where it has moved horizontally, if it's moved left or right, is to keep the same y value for the point, so 0, and then figure out where the x is now. Okay, so I'm going to figure out what happened to that point by keeping its y value at 0, but then I'm going to see what the new x value is. Now, this is a pretty easy equation to solve as far as a quadratic goes because we can solve it using square roots. So if I take the square root of both sides here, that would get rid of the squared. I'd have square root of 0, which is 0. Now typically, well, always, when we take the square root of both sides in an equation, we actually end up with a plus or minus here. But since it's 0, we obviously still just have 0. So I'm going to erase that. And then I'm left with just x plus 1. Now this is the key right here, what happens. When we solve for x, we subtract 1 from both sides. And then x becomes negative 1. So our point that had a y value of 0, remember we plugged in 0 for y basically, it has an x value of negative 1. So we've moved over to the left, negative 1. Why did we move to the left? It's because when we were solving the function, or solving the equation set equal to 0, we had to do an inverse operation. That's why we end up kind of doing the opposite of what we see as far as inside the function with x. It all has to do when we're solving the function, setting it equal to 0, or getting the x by itself. And so the same thing will happen with all the other points. They will all move to the left, 1. So our new function will be over here. Now that's just one example. Another example that I'd like you to consider, perhaps on your own, is if you had your parent function maybe the square root of x. My question to you would be, what does the new function that's transformed from that parent function, the square root of x plus 1, look like? Well, maybe even make it a plus 2 and see what happens. And do it in this same way. So graph your square root function, make a table if you need to, and then set this function equal to 0 and find out, where did that beginning point go? Which way did it move, left or right? How much did it move? And that's telling you how it moves left or right, because remember, we're keeping our y value the same. So you'll see when you go to graph this function what the y value is for kind of the starting point of the square root function. And then you'll be able to keep that y value the same for that starting point and figure out where the x value moved. So this takes a little bit of practice, but looking at some examples like this will help you to figure out what's happening every time, why the function moves to left or right. You might even try graphing something like, instead of it being x plus 2, you could maybe do something like your parent function is the cubed function. And then if you wanted to graph a horizontal transformation, you could graph x minus 1 cubed. And maybe even just plug in some numbers. Make a table for the first function, make a table for the second function, and then ask yourself, where did each point move? Why is it moving that way? All right, good luck with this. This is a great investigation type problem, and it can really explain a lot about graphing. So let me know if you have any questions about anything related to transformations.